Ladies and gentlemen, this is the 2.4 Day 2 Solving and Graphing Compound Inequalities instructional video in which we'll explore special cases for solutions. The teaching point today will be to learn how to solve compound inequalities with special solutions. The success criteria will be to show our work and graph solutions. Take a moment to pause the instructional video and jot down this first example. Okay, so what we're going to do is we're going to go ahead and solve each inequality. So I'm looking at the first one, and I'm going to start by subtracting 11a on both sides. So I'll get negative 7a plus 8 is greater than 15. Subtract 8 on both sides, and I'll get negative 7a is greater than 7. Divide both sides by negative 7, and I'll get a is less than negative 1. So remember, when you multiply or divide by a negative, you have to flip the inequality symbol. All right, so that's the first portion of my solution. Now I'll go ahead and solve the second inequality. So I will add 3a to both sides. And after I do that, I'll get 13 minus 11a is less than or equal to 13. I'll subtract 13 on both sides. I'll get negative 11a is less than or equal to 0. I can continue to solve by dividing by negative 11. All right, and then I'll get a is greater than 0. All right, so when I go to graph, remember with and compound inequalities, the solution needs to be the double overlapped area. So here is 0, here is negative 1. So if I'm graphing all of the solutions that are less than negative 1, I will be shading to the left. If I am shading all the solutions that are greater than 0, I'll be shading over here to the right. Now, one thing I want to point out is our original compound inequality said that this was an and. So my solution on the number line would be the area in which there's double overlap. So when I look at my two solutions here, a has to be less than negative 1 and greater than 0. That can't happen because there are no numbers that are both less than negative 1 and greater than 0. And if you look at my graph, there's no area on the graph in which there's any double overlap. So the solution to this inequality, this compound inequality, is that there isn't one. So no solution. Oops, there we go. So my answer is no solution. All right, ladies and gentlemen, go ahead and pause the video to jot down our next solution, or equation, compound inequality, I should say. Here it is. Take a moment to pause now and jot down this compound inequality. Okay, just like the last example, I'll go ahead and start with the first inequality. So I'll subtract 20 on both sides. And I'll get 2r is greater than or equal to negative 20. Divide both sides by 2. And I'll get r is greater than or equal to negative 10. So that's the first solution. Moving on to the second inequality, I'm going to add 9r to both sides. And I'll get 8 minus 1r is greater than or equal to 15. Subtract 8 on both sides. I'll get negative 1r is greater than or equal to 7. Divide both sides by negative 1. And I'll get r is greater than or equal to, so again, I divided by negative 1, so really I need to switch that inequality to say r is less than or equal to negative 7. Okay, so my solution here is r is greater than or equal to negative 10, or r is less than or equal to negative 7. Now I need to go ahead and graph. So I'm going to jot down a number line here. Here is negative 10. So I need to shade all the values that are negative 10 or greater. So it's going to be everything over here to the right. Or, here's negative 7. I'll put it right here. Any values that are negative 7 or less. Okay, if you take a moment to look at my number line, you'll notice that the entire number line is shaded. There isn't any open areas on the number line indicating that there's not all real solutions for an answer. So my answer here, because the entire number line is shaded, really isn't these two inequalities. My solution really is all real numbers, because there isn't a number on the number line that doesn't work. All right, ladies and gentlemen, go ahead and press pause on your video and jot down this last example. Okay, just like in the other two examples, we started with the first inequality, so I'm going to start by subtracting 7p on both sides. And I'll get 1p minus 13 is less than or equal to negative 2. I'll add 13 on both sides. And I'll get 1p is less than or equal to 11, which is the same as p is less than or equal to 11 there. Okay, I'll go on and move on to the second inequality. I'm going to subtract 2p on both sides. I'll get 20 plus 2p is less than 14. Subtract 20 on both sides. I'll get 2p is less than negative 6. Divide both sides by 2, and I'll get p is less than negative 3. So what I need to do right now is I need to put together a number line, and I need to shade the areas of double overlap, again because it's an and compound inequality, of all the values that are less than or equal to 11 and the values that are less than negative 3. Remember, my solution area is only the area that's double overlapped. So less than or equal to negative 11 would mean that I would shade negative 11, and it would be the values over here to the left. And the values that are less than negative 3 would be the area in which, if I circle negative 3, that's not a solution. And it would be every value to the left. Now again, remember, because this is an and compound inequality, only the values that are in the double overlapped area are considered solutions. So when I look at this area right here is the only area on the graph where the number line is double shaded. Negative 3 isn't a solution for p is less than negative 3, so negative 3 technically isn't a solution or in the double overlapped area. So in this particular case, we have an and compound inequality. The solution is going to be the values that are less than negative 3. So here's my solution. And my graph, if I can shade it here, is going to be this area I shaded in yellow. So it's going to be an open circle for negative 3 and everything shaded to the left. Because again, those are the only numbers that are shaded, double shaded for both inequalities. So my solution is p is less than negative 3, and this is what my graph would look like. All right, ladies and gentlemen, it's your turn. Go ahead, pause your instructional video, jot down these two compound inequalities, and check your solutions and graphs in with your teacher when you're finished. Good luck.